So let's continue here, checking our collisions. And like I said last time, we sort of created all these variables here, and we did all these measurements and so on. Now we actually have to start using them to check the collision. Now, one thing that I would sort of mentioned as well was that we need to be able to update the Y position. So the computer paddle max and min, those are sort of static. Same with the player paddle one. But because the paddles can move vertically, the Y positions are going to change. So what we're going to do first is right in the check collision function here, we're going to update these. So I'm actually just going to copy them because there's so much similarity here. They'll be easier just to change them. So just be careful though, you do have to change them up. So player paddle max, well, we're going to deal with the Y's here. Okay, so both of them on the Y. And so the player paddle dot transform dot local position dot, you guessed it, change those to Y. We're going to either add the player height or subtract the player height. And it's the same idea as before. We've got the center here, and we're just adding or subtracting half the height. Okay, and basically the computer paddle max and min, we're going to do exactly the same thing. So change those to Y. And so paddle computer dot Y. Whoops. And so none of these, you shouldn't get any red or anything. All those variables should be defined. And then of course this is also going to be height. Okay. So once you got those done, okay, we basically did what we did above, but now we're going to be able to update these when we call the check collision. Okay, now we could actually do some detecting here. And so we know that we're going to have to return a true or false. And so basically if, you know, they're in collision, right, they're in contact, we're going to return true. If not, it's just going to return false. So we have to have a couple if statements here. And we're going to basically check in terms of the X and then also in terms of the Y. So let's just get this in here. So we're going to transform. Remember, this is on the ball. So we don't have to refer to it as the ball.transform, just the transform.local position dot X. So we're going to deal with the X first here. So minus the ball width. So we're going to, do the exact same that we did before. So this is going to be the bottom of the ball. Divide that, just format it nicely. Divide by 2. If it's less than or equal to, okay, the player paddle max X, okay, and so it's going to be 2 here. So it's going to be basically within this, and the transform dot local position plus the ball width, dot X, dot X plus the ball width divided by 2 is greater than or equal to the player paddle. So it's going to go off the screen here. I'll move it over. So player paddle min X. Hopefully that's okay. Good. Okay. So basically, if it's within, basically if the ball is inside the inside the paddle, right? There's a collision occurring. So we've got that going on. So we're going to check that first. Notice I put that curly brace at the end there. And we're going to sort of check another thing too. So basically, if it's in terms of the Y. So you're going to find something very similar here, dot local position. So if the position of the ball on the Y-axis minus the ball height divided by 2 is less than or equal to the player paddle max Y. Hopefully that works out. Yep. And transform dot local position dot y plus the ball height divided by 2, okay, is greater than or equal to the player paddle min y. So with those two conditions, we're basically just checking to see if the balls collided, okay, either in the x direction, okay, so horizontally, or vertically there, and that's basically what that bit of code is doing. Now, of course, we gotta, what happens if they are in touch? All right, so like I said, we're gonna make sure that we can check this here, and so, yep, we got the two conditions. Now, I just sort of thought about this a little bit more, and we're going to run into a bit of an issue if we do the equal to. We don't want it to actually go inside it, otherwise it gets stuck. So just get rid of those equals to, and just make sure it's less than or greater than on all of those. Okay, so just a minor little thing, so just get rid of the equal sign there. We'll run into a problem if we don't. Okay, so if we've got this here, basically if it's in collision, right? So if the ball is where the paddle is, we're going to do a couple things. We're going to bounce it. So to get it to bounce the other way, we'll just change the ball direction. Okay, so we know before we had set it to left, well, we're going to bounce it back the other way. Vector 2 dot right. You could also do negative left, I believe. That would work out. Can't spell. Another thing that we need to worry about is that we don't want it to look like the ball goes into the paddle. So what we're going to do is always make sure that the ball, so the transform.local position, is that not suggesting here? Local position should be okay, is a new vector 3. And we're basically just going to move it over a little bit on the x-axis. So what we're going to do is we're going to set the paddle, player paddle max x plus the ball width divided by 2. So that will just make sure it's to the right of the paddle always. It goes to the edge but doesn't go in. And then we'll just keep the y and the z. So transform dot local position dot y and local position transform dot local position dot z. So those two stay the same, but we're just going to shift the x to make sure that it doesn't go inside the paddle. And then we have to sort of return something. So we're going to return true. Sorry, this is not Python, it's lowercase there. So it's going to return true because this is, like I said, it's a Boolean, so something has to come out. And so this pathway will return true. We got to close up. That closes the first if. That closes this. Whoops, that closes the second if. The third if, or sorry, third sort of thing, we need to always return something. So if it doesn't actually collide with it, we need to return false. Now, we still have to get it to check this. We actually haven't called this function yet, the check collision. So what we're going to do is in the move, okay, which is going to be called all the time, if check collision is false, right? Like if it's not colliding, it's going to move. So what I'm going to do here is if not check collision. Okay, so if check collision, if the outcome of that is false, then then it will transform and move in that direction. Okay, so this should work out. Hopefully there's no errors, right? So we basically added on with those conditions there, we've got the movement going, and then we've got the return values, either it's going to collide or not. If it does, it changes its position. If not, it just keeps moving along, right, as it did before. So we should be able to see it work with the player paddle. It won't work with the whatchamacallit paddle yet, with the computer paddle. Let's just see here. So let me just move this out of the way. Hopefully that error disappears. I think I fixed that up. Okay, so there. Okay, now it did stick, so let me just sort of figure this out here. All right, so the little error there, which was a little bit surprising, is I thought I had changed that by doing the minus and the greater than rather than less than or equals to there. The trouble is this divide by 2, and it's just putting it right on the edge, so it's still in collision. What I found is, fix it up, I just went 1.99f, and that seemed to solve it. So if you're having that trouble, just divide it by 1.99f. Visually, it won't make a difference, but play-wise, it solves that problem. So now when I hit play, it moves to the left, okay, hits the paddle and bounces back. Now obviously it's going to go through here, and we basically just have to almost do the same thing we did with the computer paddle with just a few changes, okay? So we're going to go back to the script and then work on, like what we did with the player paddle, we're going to do that with the computer paddle. So basically the player one is going to be identical to this one with some changes. So I'm just going to copy all of this and paste it again here. And like I said, just a few things are going to be reversed. So because it's going the opposite way, so we're going to change this one, local position dot ball. So on the X plus the ball width is going to be greater than the computer paddle max X and transform X. So this one will be minus the ball width divided by 2 and then computer. Okay, and then the same idea with the one below. So transform plus the ball height divided by 2 is less than, so that makes that greater than. Actually, I guess we can keep that one because this actually will stay the same, right? Because it's going to be on the y-axis, so that doesn't matter. So I'm just going to change this to computer and transform to local height plus the ball height divided by 2, and then the computer here. So I think we're okay. So plus the ball height. Oh, and make sure this is minus the ball height. Sorry, I didn't need to change that because it doesn't affect it on the y-axis. So make sure you change that back to negative. Okay, everything stays the same on the second line except for the computer gets changed there because it doesn't matter which side we're on. Obviously, now this number here I'm going to have to double check, but what we'd have to do is set that to negative. I think it's going to have to be like divided by 2.01 just to make sure we're okay, but we'll just double check that when we play. And obviously we're going to bounce it back to the left here. So hopefully, if I didn't make a mistake there, it should run. The only thing I'm a little bit worried about is that 1.99f. We'll see that and fix it if we have to. So let's see. So now it should bounce back and forth. One, that's good. Okay, a little bit of a problem. Okay, I forgot. It's actually moving it player paddle. So let's make sure this is on the computer paddle. It's a problem when you copy and paste. And we'd have to add the ball width. Okay, I was all worried about that. So let's see if that works. I still think there might be an error. Hopefully we can get this done before the video ends. Come on, computer. Let's see, bounce. Yeah, it gets stuck. A couple things there, so we saw it on the wrong side. So what I'm going to do is we're going to have to subtract that, right? Because that has to be on the left side now. And I think I'll just preemptively do 2.01. Okay, so hopefully that saves and that works. And the video will cut off right here pretty well. So let's just see. Hopefully we can see it bouncing, and then we'll go and do some trigonometry in the next one. We'll fix that up in the next video.